Hi guys, I'm Anis here, and in this video you will learn how programming with SDL2 in C++ inside of the Neovim on Windows. And I need to remember how to don't touch the microphone. I planned this video since the day one of this channel, but not planned. I've been thinking, how can I share my passion in game development on this channel? Like, how can I record more videos and learn more things along the way? And the game development itself brought me in the world of programming, because first of all, back in the days, I enjoyed playing Amnesia and other old games, and you can see the Amnesia on the background. And first of all, I played the game, then I decided that I want to change the game. Then I deep dive in the game development and how I can change it, and in the programming languages, especially in C and C++. I've started learning the programming skills and IT. That's the beginning of my career, but I've never worked like a game developer. Mostly I've been working in my free time. I'm programming some games. Programmed in pure C++, and that was pretty complex. Still nowadays I watched my code and I am amazed how I programmed in those days. And in the beginning of everything I started programming with C++ and OpenGL, but OpenGL was really difficult, and I need to implement a lot of boilerplate code, and I need to integrate with a very complex Windows API, and that was really problematic. And later I discovered SDL2, and the SDL2 that was kind of the breeze to developing a high level of APIs. Some very cool games, but you still need to implement the game loop, you still need to implement the delta time and all of these things that make your game a game. And I decided that okay, I remember those times I've been using some tools, and now I want to share that, how we can program in games, not with the game engines, I know that too, especially the Unreal Engine, but how you can program in games in more the craftsmanship work, when you can programming in the SDL and working on your game engine. And I think it's really cool when you can use the programming, when you can program everything what you want, implementing the artificial worlds, when you can guide the people through the game and you know how your game works. I mean, you know how your game loop works, you know how your delta time calculated, you know how your game is organized. I think all of this is pretty much awesome to do that by yourself, because you immediately see a lot of work that you implemented in your game. Everything starts with the website, and this is the leapsdl.org, the website of SDL, where you can download SDL, mostly the compiled libraries for different targets, for Windows or for Linux, and even the source code if you want to compile it by yourself. And in general, SDL is a simple direct media layer, and it helps you to render something on your screen and listening to operation system events like key pressing and mouse movement, and the window size resizing, and many more others. And that's pretty much it. But for the second part, you need to find Cmake, and Cmake, it's a builder tool that helps you to link the SDL libraries to your code in C++. And without the Cmake, it will be much more harder than with Cmake. So Cmake helps you to implement and build it simpler. So you need to download it and install this tool. And the last tool you need, this is a VCPKG. So VCPKG, it's a package manager or library manager for C++. And if you're programming in JavaScript, you know the NPM, or if it's Rust, you know about the cargo. And VCPKG, it's something similar to all of them. It helps you to managing your packages. And we'll start with the VCPKG. To install the VCPKG, we need to clone the repository. Let's do this. download it, done. The next, let's run this bot script. And it looks like we are done. To install the Cmake, you need just download it from the website, select that what more acceptable to you. For example, the from Windows source, or no, you don't need the Windows source, you need the Windows x64 installer, or select your Windows architecture and then run it and install it in your system. If you have a Cmake, you can verify the Cmake version. So my Cmake version is 3.23. Let's go inside of the VCPKG directory. And here we have a VCPKG exe. You can run it. No, I'm pretty much sure that it's here. So we can run it. There is plenty of this command, but I need to install a package on my Windows machine. And VCPKG download the source code for my library that I need and compile this library. So you can check how to do that here. So you can use the VCPKG install and specify what you want to install. So in my case, I want to install SDL. Let's do that. VCPKG exe install SDL2. Then I want to specify x64 Windows, and I want to have a static because it will be much simpler. So SDL is installed. So it already helps us what we have to configure in our Cmake file. So let's create an SDL project. So I want to create a directory and let's name it my game. Then let's go inside of my game. Now we are ready for Neovim. So we need to install LSP C++ server. For that, LSP install C++, and it's already installed. We are ready for creating a directories. Let's start with source, the most important one. Then build directory, where we'll put our binaries and the build results. Then let's create a couple of files, and first of all the Main.cpp inside of the source, and the Cmake list for build configuration, and Cmake presets JSON for the presets of our build system. And that's the bare bones of our new project. Then let's go with the Cmake list, and we need to specify a couple of fields. So Cmake minimum required and version 3.23. This is my version. And the second, we have to specify the name of the project, my game, and then add executables. And my game source main.cpp. Let's save it. We have to find SDL2 package, and for that we can use a find package command, and we want to find for SDL config required. Save it. I'm going to link SDL2 to my game. And for that reasons, I can use the target link libraries. That's my game, then private. And I want to have SDL2, then SDL2 main static. And that's it for this configuration. We have to set the version, the name of the project, add executable files, find the package, and link the packages to our project. That's it. Next, Cmake presets to configure the properly built system. And I'm not going to typing everything by myself, but just paste it. And here, if I'm going to explain it, we have a version, configure presets, name, and a toolchain. Here you specify the chain that points to your VCPKG root, and you have to specify this variable inside of your environment variables, then it leads to scripts, build system, VCPKG Cmake that helps Cmake to properly figure it out where the libraries are. And then the cache variables, VCPKG target triplet. Here you specify the x64 Windows static or wherever you like. And I think, yeah, just for simplicity, I want to keep it debug. But if you want to configure the proper presets, if you want to build it with static, you use x64 Windows static. But if you want to build with the dynamic libraries, when you have to put the .dll file inside of your directory where your .exe file is, then you have to specify just x64 Windows. But I installed the static one. To me, that's more than enough. Let's save this file. That's it with Cmake presets. Okay. And then next I am going to implement our C++ file, and let's start. So int main argument counter, then our arguments, gv, and then return 0. Here we go. Then let's include some important streams, save it, and include SDL2 SDL.header, our SDL header, and file not found. Sounds horrible, but this error means that our Clangd couldn't find this header anywhere, so we are not specified that, and it's not in our project directory. So we have to somehow tell our Clangd where to find this header, and it's pretty much simple. We have to specify the config for Clangd. So for the config, probably you know about the folder local app data. Yes, of course, I forgot about the env. So local app data. And we have to go inside of this folder, env local app data. And inside of this folder, we have to create Clangd directory. Then we have to create inside of this Clangd directory file config.yaml. Here we go. I'm going to copy paste it because I already configured it and just showing. And inside of this folder you have to specify the path, so it should be here. Compile flags, then you have to add the compile flag, and it should lead to your VCPKG installed, and then if it's static, then it's static, or if it's not static, you remove this word, but you have included. Save it. I'm not going to implement every single part of the program, I will copy paste it, but let's check out if the SDL here. So SDL init, and what if we put the SDL init video, and if it's not equal 0, you verify for the error. If it's error, then SDL error, sir, then SDL init, and let's return the error. That should be SDL get error, and you see that everything works. We can get SDL command and everything works. SDL is recognized, so we even can go deeper. Yes, we can go there, and we can see the documentation. That's the first part of the SDL. We need to initialize the SDL in our environment and check that everything goes correctly. Then we have to create a window. I'm going to copy paste that because I don't want to write it down. So now we have a window, and here you specify the title of the window, position of the window from the left top corner, and then side of the window, and then I want to use the OpenGL inside. Then we have to verify that everything created properly,
this one. So Windows is not equal null PTR, no, not is a null pointer, and if it's not null pointer, so please exit, quit the SDL and return the printer error in the console log. Then we have to create a renderer based on our window. The renderer, it's a part where we're going to render our application. Done, and it's inside of our renderer. We want to use the vsync, for example, and we want to accelerate it by our hardware. The renderer is here. Let's add the comments. So create window, then we have to create renderer, then the next one. Work already with that. I think everything is set up, so we create simple game loop, the simplest possible, not actual game loop, but just yeah, let's even rename it, not the game but event. That would be better name for that. Clear our screen. So first of all, set renderer draw color. This is a color. When you re-render the view of your window, it will be, this color will be used. And then I do this renderer clear, so filling this with this color. Then the part with the loop. I want to loop until cut is false, sorry. Then I want to pull the event inside of this event, so I create the variable and transfer the reference. Whoa, from the first perspective it sounds a bit, it looks a bit insane that I'm transferring the variable, and the value will be set inside of this variable. So I verify the type of the event is SDL cut, and then I set the cut true, and then if event type, I verify that someone pressed the keyboard, and then I verify that the key number is escape if someone pressed the escape, and then I exit the while loop. And also each time I re-render the screen. Let's continue, and then we have to finalize our application, and we can finalize with destroying the renderer, destroy the window, and cut SDL. I think this is the best way to implement the simple as possible SDL application. If you'll check how it looks like with the Win API, oh my god, it's a way more complex and cumbersome than this implementation. It looks clean and very short. So unbelievably, but this is more than enough to create a simple window on your screen and render something in this window. So it's kinda the prerequisites for the next game that you're going to implement, or game engine, or whatever. Many companies use this. I mean, everything starts simple, and this simple, but it's background for the large and huge things. And the next, what can we do? It's build everything. So let's start our console. We created the build directory. Let's go inside our build directory, and here we have to first of all configure Cmake. So from this directory, I pointing Cmake outside of this directory to Cmake lists.txt and Cmake presets.json, and I want to use the preset debug. We see our presets here, they configured. Here we go. Everything is fine. If you close this and check the directories, so it configured everything, including the solution project for Visual Studio Code. For Visual Studio. Now we are going to make it. So Cmake build and this directory, because we have a configuration here, and run. Done. And you see this line. Executable file exists in a debug folder. So let's run it. Debug mygame.exe. Look at this brilliance. When I was a teenager and I done this, I was so happy to see that. It was absolutely impossible. In the school I've been programming in Pascal, and mostly the output was inside of the console, and that was a stupid some mathematical calculation. But here I built a real window. I render it like real game engines, like real games. When you can start adding more things, configure your characters, your world. I felt like a god who can create their own world inside of this simple tool and share my world, my perspective with other people. That was goddamn amazing. Just a short off-top I want to show. When I was a teenager, I've been working with the code blocks. This guy. And let me show you. So the code blocks, this tool, it's unbelievably, it looks exactly the same like back in the day. So I want to open existing project. So I've been programming in a pure white theme, but using the mouse, and well, it's not really nice. Probably I remember that I need to create a project, and I use the pure libraries and put them inside. So I download from some websites and put these libraries inside of the project to link my implementation to them. That was something amazing. So I even didn't know that command contains exactly this name, or when I tried to compile that, then from the compile I learned that I used some wrong naming or something. But nowadays with the Vim, with the Neovim, it's pretty much simple. It helps you to do everything. It contains everything. You can use the outliner. It helps you to work with that. All you need to do is configure it initially, or use the Vim. And to me, it looks much friendlier than this. It looks like something from the past, but still awesome. I have the good memories programming with this tool. So the video is finished. Don't forget to like and subscribe, please, it's important. And yeah, I hope I inspired you to build maybe some games, to write some simple games, or at least to try it out how it works. And yeah, thanks for watching, and see you next time. I'm going to do more videos like this because I like this theme. I like the programming with SDL. So see you next time.